Good morning, everyone. Thank you very much for joining us today. So this is the latest in a series of Q&As which we're organizing to discuss issues of importance for the container glass industry, but also those issues that might be interesting also for our customers and for the value chain that's involved with container glass. And so we invite experts to talk about different issues. And we are pleased to welcome you all today to this particular issue. My name is Adeline Farrelly, and I'm FEVI Secretary General. And FEVI is the European Association for Container Glass, representing over 90% of container glass manufacturers in Europe. So today's discussion, I think, is quite timely because it comes just after Zero Emissions Day, which took place last week. And we want today to reflect on how the glass industry is working together to achieve carbon neutrality and to reduce the emissions from our furnaces so that we can make glass an even greener packaging. Now, today's Q&A obviously takes place in a very challenging environment with energy costs skyrocketing, raw material shortages, consumers having much less money in their pockets, which will also reduce their ability to spend on discretionary expenditure. And so this is all combining to create a very big negative impact on the market when we're all under pressure. But we're also, while facing these challenges, we're under pressure too, including brands and retailers and ourselves, to live up to our sustainability commitments. And as packaging suppliers, we are committed to supporting our customers to help them deliver on their sustainability commitments. And the best way we can do that is to make sure that we live up to our sustainability vision. So maybe I should say that today's Q&A is not about today's challenges. It's not about soaring energy prices. It's not about the shortage of materials. It's not about soaring inflation. It's about the future. This is a future-looking event, despite the problems of today, because the challenges today will end one day, and we need to be ready for when that moment comes. So as you will know, between now and 2050, the container glass industry is aiming to achieve a major revolution in how we make glass to make sure that it's fit for a climate neutral economy. And that is what we call the joint furnaces of the future vision. It's basically a common vision of the industry to decarbonize our production and really to make massive cuts in carbon emissions. There's an awful lot of things happening across the industry, from hybrid technologies to cutting edge furnace technologies. And today we're here to talk about one of the most recent examples of this commitment to furnaces for the future vision, the Vercain project. And this is an ambitious R&D program that looks at how carbon neutrality can be achieved across the French glass manufacturing industry. So to explain how this project can pave the way to climate neutral glass packaging solutions, I would like to introduce our speakers today. So first, may I introduce Frédéric Rougevin-Baville. He is the Furnace and Glass Melting Group Manager of Veressence. Veressence is a leading glass manufacturer supplying the perfumery and cosmetics industries. Welcome, Frédéric.
Hello, everybody, and I'm pleased to participate to this exchange with you.
Thank you, Frédéric. And Ludovic Vernon, welcome. Ludovic is the Future Industry Lab Manager at ENGIE Lab Cryogen. And Cryogen is the research arm of ENGIE, which you will all know is a global energy supplier. Welcome, Ludovic.
Thank you. Thank you for the invitation.
And finally, another Frédéric, we're going to have some difficulties today to make sure we're talking to the right Frederic, but Frederic Dupuis is R&D Director at Saverglass, and Saverglass is a specialized glass manufacturer to the high-end, producing high-end glass bottles. Welcome, Frederic.
Good morning at all, and thank you for this invitation. Thank you.
So let's get started. I think first off, Ludovic, let's turn to you. Can you talk us through the basics of what is the Vercan project all about?
Yeah, for sure. So thank you again for the invitation. We are very happy to share on our Vercan partnership. And so basically, as everybody may know, the elaboration of glass emits massive quantities of CO2, and mainly during the melting phase. So we speak about in between 250 kilograms of CO2 to half a ton of CO2 per every single ton of glass. And this, even if you collect recycled glass, because you need to melt it again. So we have these emissions that are mainly due to the fact that we burn fossil fuels like natural gas in these furnaces. And so we need to reach very high temperature to melt the glass. So that's our basic problematic. And so solving this problem is not at all straightforward. And so we came to the fact that we had to mobilize complementary competencies. And so that's the origination of the Vercan project. And we have the chance to combine the expertise of glass makers, of course, so Saverglass and Veresence, a furnace expert, which is the fifth group, and a global energy supplier, ENGIE, that is particularly active on low carbon energy vectors. And so that project was supported by the ADEME, which is the French Environmental Agency. And so our main ambitions on Vercan were, if we want to phase out from fossil fuel, how do I map the potential low carbon options? That's the first thing, that are realistic on a technical point of view. And so that's why we worked on low carbon electricity for sure, but as well biogenic sources of energy and low carbon hydrogen. So we covered the main energy vectors that could be low carbon. And from this set of options, we put in place a methodology to explain what does it imply in terms of need for new infrastructures, for example, logistics, organizations, new jobs, new need for new competencies, and what are the new constraints in terms of operation and maintenance, which are really key aspects. And so globally in Vercan, we assessed more than 30 criteria that enter into a decision making. And so on the top of that, for sure, our target is to have a positive impact on CO2, but in the same time, it must not be offsetted by a new negative environmental impact. So that's, for example, the impact on land usage or on particulates, etc. So we have put a very special attention on that point to address these potential border effects. And so we really applied this methodology on real cases. And so we had the chance to work on 3 plants located in France. And one of the main takeaways is that each particular context influences the final preferred solution. And so, and in particular, we realized that it was possible to mobilize resources that could be available on the territory in the neighborhood of the plants. And so this is what is Vercan was about in a few words.
Okay, thank you. That's interesting. So it's really trying to adapt solutions, decarbonized solutions for each of the plants in the different locations. So a customized solution for each plant. And maybe on Frederic at Veresence, Frederic Rougevin-Balville, maybe you could describe your specific project and the sort of things that you were looking at and you were testing that would suit your plants.
Sure. So for us, first, it was something very helpful because, for example, we have different size of furnaces, different technology, and for some, it is difficult to find it on the shelves of the suppliers, or on matching existing technologies or even future available technologies. And through Verkan, it was really possible to assess and find solution for each of our furnace and how to decarbonize our process. And when we talk about this, it is really about furnaces, but also about all the process. And for us, it was really first to study and assess our CO2 emissions for each part of the process, furnaces, canal distribution, forwards, polishing, and the rest of the plant. And then it was really through a specific methodology to look for what is currently available as technology and what would be available. And we are talking about electricity, hybrid furnace, hydrogen, syngas, biogas. And it was really to study all these parts and apply them for Veressence in Mers-les-Bains. For us, it was really important to make sure the solution can fit our specification. And a specification, for example, yes, we are in the middle of a turn, so it is very important to make sure we respect our environment locally and try to improve this part. And through Verkan, it was possible really to look for technology, environment, and also social, economic around the facility.
Mm-hmm, mm-hmm. Thank you, Frederic. Because Ludovic mentioned that the project was examining, I think it was 30 different criterias, which is quite a lot to explore. Turning to Frederic Dupuy from Saverglass, can you give another example of the typical parameters that you explored as part of this project?
Yes, of course. For the Verkan project, we chose to limit yourself to the scope of extra filling glass, which is very specific to us. And we have explored the 3 areas. So first was electric melting for a tonnage of 150 tons per day. And we can consider that 150 tons per day in extra filling glass is beyond the recognized know-how. So with Verkan, it was a very good opportunities to realize a technical study on an existing Saverglass furnace to identify and to evaluate the risk and the financial aspects. The second area was hydrogen melting. We were able to define the necessary infrastructure depending on the percentage of hydrogen in the natural gas and the associated economic parameters. And the third area that we see with Project Verkan, it was the biogas. And as for the hydrogen fusion melting, we have now a good understanding of the processes and the constraints of the operation. We also have an assessment of the energy potential of the territories of our different plants. And to finish, with Verkan, our exchanges help us to analyze the different possible scenarios with a structural and quantified approach.
Mm-hmm. Thank you, Frederic. I mean, we're 2 years into the project at this stage. If I remember correctly, it started a couple of years ago. Ludovic, what are the main learnings then and findings so far this project? What can you tell us?
Yeah, at first, very good news. We have proven that, we can achieve very low levels of CO2 emissions. And it's not a dream for the long term, but it's something that can be implemented at short term. And so basically, this topic is around 2 main parts, upstream. The upstream part is how to mobilize the good quantities of low carbon electrons or low carbon molecules in the right quantities with the security of supply all along the year, and as much as possible, a visibility on costs. So that was a big part of the project. And downstream, the other part of the project was, what about the technologies and mainly the furnace technology? We need to switch for a new technology which can be in rupture. So it's not an incremental change, but a rupture change. So it's clearly not business as usual.
Yeah.
And so we have clearly defined what kind of question is key. And we have highlighted the kind of risk that must be addressed. And so, yeah, we have proven that even if it's not a business as usual decision, can be made and deployed at scale and in time, because as you may know, we have very short targets to switch towards zero carbon furnaces. 2050 is tomorrow in such an industry.
No, I know. We know that very, very well. I mean, a furnace lasts maybe 10, 15 years. So we're less than two furnaces away from having to achieve climate neutrality. So we're very aware of the big challenge. And as you say, it's not just business as usual, it's total disruption. But on this, I just have a question, because clearly what the project is saying is that there's no one size fits all solution for all the different furnaces in Europe. There will be different courses for horses, if you like. And, you know, every source of sustainable energy has also its downside. I mean, it's not without some problems. And you mentioned biomass, and here in Brussels, there's a lot of discussion at the moment about whether biomass is really sustainable. What were your learnings from the Vercan project, Ludovic? Is biomass okay?
Yeah, basically biogenic sources in general was a focus of the project. And in the container glass industries, most often these industries are in the middle of countrysides or near forests. So the question of biomass is legitimate and can be mobilized to fire the furnaces. And we have proven that basically on the three cases that we addressed, we can go at more than 20% of the energy mix that could be brought by biogenic sources. But that's a very good question. We can ask whether this kind of energy vector can bring some controversies. And yes, it could bring controversies. And so in Vercan, we put a lot of efforts on assessing with most rigorous methodologies the life cycle assessment. And so we have included about 10 environmental impacts on the whole value chain. So not only on the firing brick, but as well on the upstream value chain of biomass and the downstream one. And so on the top of that, we have the legislation, which is key and which is in evolution. And so it may impact the final choices. But what is sure is that with that project, we have all the tools to assess and quantify the impact of the energy value chain and compare it with the current impact of the glass value chain. Okay.
So it's not no. There is a role for biomass, given that some of the plants are actually situated very much in rural areas where there is actually access to sustainable biomass sources. Okay, so maybe let's go and say, okay, what does all this mean? I mean, what can we expect? So in terms of implementing these findings and the projects that you have foreseen in your companies, what's on the horizon for your plants? Do you plan to incorporate these findings, and what can we expect? And especially, you know, with the global energy crisis, is it putting a stop to maybe some of your plans to implement the findings? So can I maybe start with Frédéric Dupuy from Saverglass?
Okay. So for Saverglass, we defined our carbon neutral roadmap at the beginning of 2021, which vision until 2035. So it will be, in also case, a very long journey. With actual crisis, there is no doubt that the current energy crisis is very disruptive in the short term. But this crisis does not call into question the long-term goals or the medium-term emission reductions. And probably this energy crisis will have a benefit effect on the faster evolution of our energy mix.
Mm-hmm.
So
okay. No, sorry, go ahead.
Oh, thank you. So with Verkan project, we were able to evaluate orientation and had not been taken into account at the beginning because they were not considered more enough at the beginning. Now with Verkan, the Verkan project allows us to have access to information to complete our positions. And we have different studies on the way at present. These studies are complementary actions, additional actions to our reference roadmap in order to be reduced step by step our carbon footprint and at the end to be able to be ahead of the initial planning of our roadmap.
And the initial planning of your roadmap, the date was when?
It was for 2035, and
Okay, good.
we defined some of the first actions, the main action after 2025, and now we will start with additional action, and we will have capacity to start specific action to reduce and to improve the performance regarding the emission on our furnace before.
Very good. The other Frederic, Frederic Roos van Baville, Ferressence, what can we expect?
So you were talking about crisis. Yes, we are facing crisis, but let's say for us, it's just a bump and on the plan, but the target stays the same. Really, we plan and we announce our CO2 reduction through SBTi plan, for example, and we communicate our first project will be in Meurs Furnace 1 with the electrification of the furnace. And we have planned for the rest of the furnaces and processes, the rest, and we stick to the plan, and we will achieve this target. And really, with Verkan, it was possible to check each possibilities and not to have only one solution, but different solution, which is currently, for example, possible to adapt and to be more agile on this crisis. And what we will do, it's really to implement existing technology, but also new technologies. And with the time moving forward, we will have this flexibility to adapt and be on time to achieve our targets.
Yeah, that's very good. So Saverglass trying to advance on your decarbonization roadmap by you originally set the date for 2035, and so this project is enabling you maybe to advance a little bit on that, and then Ferressence project we can expect in 2025, Furnace 1. So that's really good news. I mean, just could you say, how has the market reacted to these developments? What's the response from the market? What are the customers saying? What kind of feedback have you had? Maybe Frederic Dupuy, you can maybe start us off.
Okay. So Verkan project is an initiative that has been very well received by some customers and the market. It shows our willingness to commit to the implementation of our carbon neutral roadmap and to precise our position in the spirit market. The carbon footprint of the glass container represent around 25% of the carbon footprint of our customers. So our action to reduce the CO2 emissions of the glass process will have a significant impact for our customers and to extend them the benefits of the glass packaging tomorrow. Adeline?
Yes, and really, if we talk now with Ferressence and its perspective, let's say that yes, we are using glass for a very long time. Glass is part of our society; it's part of us, and it is really a discussion between customers that yes, we want to improve our image. We want to all reduce our CO2 footprint in this industry. And this is possible, not with only one solution, but with many solutions. And what we are looking for is really to have a long-term vision. Glass is really part of us. We use it every day, make our life better. And what we learn from the past, because this is not the first crisis we are facing, glass companies always improved and put in place new processes to be able to still make glass as we are doing today. And what we want is really to create this high value and to locally reinforce jobs and circular economy. And that's what we were really looking with Vercan project, is really to reinforce this.
Thank you very much. I think I got ejected from my own Q&A there for a few minutes, so apologies. So there's a few technical issues on the back end. I don't know whether, Ludovic, you can also work as part of the Vercan project to make sure that we don't have these digital bleeps in our Q&A session in the future. We need this technology and solutions as well. Okay, so I mean, yeah, I can well imagine that the industry is, you know, it's well received, because we all need to be able to achieve our sustainability goals and reach our carbon neutrality, in fact, well before 2050. So I'm just wondering if we have any questions or comments from the audience on what we've heard today, and we can take them now. So yeah, so what I would like to, I mean, I would like to congratulate you for really looking into not only that we have to decarbonize, but really to customize. I mean, we are in the glass industry are used to customizing packaging for our customers. And so this really is a customized project, looking very specifically at a plant, and then looking at what are the resources around that plant that can be garnered and utilized in order to be able to help that plant decarbonize. And I think that's also going to have big impact on the local communities that these plants are based in, because obviously it creates local jobs and it really gives back to the community. I mean, are you working with local authorities? Are you discussing local authorities, and how is it received by the regions? Ludovic, maybe you might want to say something about that.
Yeah, maybe just to mention some classic figures when we want to mobilize a local energy, like biogas, for example. If you want to deploy a biogas project, you need to interact. If you want to generate in order of magnitude, I don't know if it's meaningful for the audience, but if we want to generate, let's say, 20 to 30 gigawatt hour of energy from agriculture waste, manure, etc., we speak about mobilizing, typically in France, let's say 30, 40 farmers that are around a plant, for example. And so this is the people we have to speak to in order to build up a project that mobilizes these energies, and then to create a plant that would deliver the biogas. And typically speaking, a biogas plant of such size would create 3 to 4 full-time equivalents, which is not nothing, just for the plant itself, but as well some good high-quality jobs for the logistics, because we need to gather this feedstock to the plant. And so globally, we speak about around 7 to 8 full-time equivalents. So that's a kind of new way of thinking to mobilize energy at scale for such industrial plants.
Question I see from Greg Morris. Has the Vercan project focused on the potential use of hydrogen in glass making? I think it has. Ludovic, can you just tell us to what extent it is looking at hydrogen, and how likely is that to be available soon?
Yeah, lots of debates for sure. At the Cryogen, we have a hydrogen lab because ENGIE is on the leading edge on the hydrogen economy. And so we have discussed at first the way to deliver hydrogen on such plants, which may be far away from big hubs. That's a problem because we have to produce hydrogen on site. Hydrogen is a vector, huh? It's not an energy that comes from the earth. Huh? So we have investigated the most mature one, which is electrolysis of water to make hydrogen that feed the furnace. But as well, we have studied what we call the turquoise hydrogen. You can still be based on your pipe of natural gas, and then you can split the CH4, the methane that is inside the natural gas, to generate hydrogen on one side and solid carbon on the other side. So you can just keep the hydrogen fraction of your fossil fuel, and the carbon one will stay on Earth. We do not burn it. And so the main problematic on the hydrogen usage at 100%, I would say, on a furnace, is that we have this initial efficiency. When we convert water to hydrogen, we have an efficiency. It's not 100%. And then when you burn hydrogen on the furnace as well, you have the efficiency of the furnace. So what we have proven is that on the global logic, hydrogen may not be mobilized as a whole and 100% on the furnace. It's better to push the limits of the electrification. And then for the last part of the energy that cannot be electrified, we can think to hydrogen. But electrification first due to the physics.
Yeah, so the future is electric.
Partly.
Partly, yeah.
It may not be full electric. It can be in some cases, but not in every segment of the glass making.
Yeah, but I think the fact that glass can conduct electricity, actually, I mean, it makes sense as well. That electrification is very important option for us.
It does make sense. A big point is that you have to mobilize large amount of electricity, and again on a site that can be far away from big infrastructures. So we may not avoid to address the upstream value chain of electrons. Huh?
But this is why, I mean, we need to make the case that we need to build renewable energy infrastructure. That is very, very important, that the capacity is put in, so that, because what we're doing is what you seem to be explaining is that we're working on the technologies to make our furnaces fit for the future, but we need the capacity, the renewable energy capacity, to be provided so that we can draw down electricity that is from renewable sources and not fossil fuel sources. Okay, so I think we should finish up there. Maybe I'd just like to thank you for your time, the speakers that joined me today, and also the audience that have tuned in. I think it's been very, very interesting. We can see that the Vercan project is really what we would say another brick in the wall, as Pink Floyd said. Really, it's another brick into building our future. I think, I mean, the takeaways that I have are really three main takeaways. First of all, it's about partnerships. And the Vercan project is bringing together all these different stakeholders to try and find a common solution for moving the factories to a climate neutral production. It's about local solutions. So really looking at, the actual local context and what suits the local context. It's not sort of blue sky up in the air thinking. It's really local solutions depending on where the industrial asset is based. And it takes into account that there is trade-offs. I mean, where it's done an analysis to say, okay, in terms of life cycle thinking, which is better than the other, given the certain circumstances that we have to operate in. So it's quite holistic. I mean, I just say, from the glass industry, this is about an energy transition, essentially. And glass is 3,000 years old, if you haven't noticed, but it is actually 3,000 years old. And the challenge today is to transition to a new energy source, but we've done it many, many times before throughout the 3,000-year history. So we're not doing it for the first time. And it's with projects like Verkane that really is supporting the vision of the furnaces for the future that we're seeing being explored in our sector and with many, many different pathways. And as you said, it's a disruptive pathway. It's far from business as usual. So for those joining us, if you would like to hear any other topics or a topic of particular interest to you, we'd be really happy to handle this in a future Q&A session. And if you have questions on today's episode, just please get in touch. We'd be happy to try to answer the questions you have. So don't hesitate to go on our LinkedIn webpage and send us your comments or questions. And please also follow the Glass Hallmark website, because it's on that website that we're posting all the different projects, the examples of the projects that are happening in the industry as part of the Furnaces for the Future vision. So with that, thank you very much. Thank you to the two Frederics, Frederic Dupuy, Frederic Rougemont,
Thank you.
and to Ludovic Ferrand. And see you all next time. Thank you.
Thank you. Bye-bye.
Thank you.